Let's talk about fractions. Welcome to the video on fractions. The first section deals with simplifying fractions. So we need to know how to simplify them, because without knowing how to simplify the fractions, we won't be able to get the final answer for the different problems that we're being given. So when someone says 25 over 20, put this in lowest terms. That's the other way they put it in some textbooks. If someone says leave it as an improper fraction but simplify and leave it in its lowest terms, that means you need to take out from both the numerator and the denominator whatever they have in common. You have to extract those. So we know that 25 is the same thing as 5 times 5, by the way, and 20 is the same thing as 2 times 2 times 5. This is one approach to look at in doing this. So if we prime factorize 25 and 20 and we have the individual factors that make up these numbers, we know that we can cancel the 5 and we can cancel the 5. So all you're left 5 over 4. So we have simplified 25 over 20 to 5 over 4. Let's look at number 4. Number 4 says, how about if we have 24 over 9? We can use a similar approach. We know that 24 is the same thing as 2 times 2, right? 2 times 2 times, let's see, 2 times 2 times 2 times 3. And then we know that 9 is 3 times 3. So we can take the 3's out, right? And then we have removed one factor they have in common. And the only thing that is left in the numerator is an 8, which is 2 times 2 times 2. I have 3. So that answer is 8 over 3. So how do we simplify these fractions? One approach is to take the number, for example, like 24, and break it down into smaller numbers. And then you can get, this is called a factor tree. You can use a factor tree to break it down to get the factors that make up that number, and then you cancel out what they have in common. That's number 4. How about number 6? I'm going to try 3 more problems from this section. Is the denominator we have 6. In number 6, we're talking about, so we have 30 over 24. Again, we can break the 30 down into smaller numbers. One thing you would notice is as you do these more and more, you would realize that there's better ways to break numbers down, or quicker ways to break numbers down. But one systematic approach you can use is what we currently have right now. And so we can continue doing what we're doing. You take 30, you break it down, you get 2 times 15. You break it down, you get 3 times 5. You take 24, and you know, of course, we did that earlier. It was 2 times 2 times 2 times 3. So you know that in the denominator, you have 2 times 2 times 2 times 3. And in the numerator, you have 2 times 3 times 5. So you've broken down the numerator to 2 times 3 times 5, and you've broken down the denominator to 2 times 2 times 2 times 3. So now we can go ahead and cancel what they have in common. So if you cancel what they have in common, so you have the 2 cancels 2, and then the 3 cancels 3. So now we have in the numerator just a 5, and in the denominator we have a 4. Now here's the thing, one thing that you can keep in mind in doing these problems. When you look at 30 and 24, after doing practice, you will realize that 30 and 24 share a number, 6. So 30 divided by 6 and 24 divided by 6. You could have gone that way. But if you don't feel comfortable just using a factor that they both have in common right away, you can prime factorize them, and then you can find your answer that way. Let's look at 4 more examples here. So we have 36 over 27. Again, when you look at 36 and 27, you can ask yourself, what number do they have in common? Ultimately, what is their greatest common factor? And if you say 9, for example, you say, let's divide both of them by 9. 36 divided by 9 is 4, and 27 divided by 9 is 3. Notice you get to 4 over 3, and you say, we're done. That's it. So this approach of using like the greatest common factor might require you to go a few steps. So for example, look at this one, 48 over 18. Let's say I don't want to prime factorize, but I want to just divide by a common factor. Not their greatest common factor, but just a common factor. Then I can divide both of these by 2, right? And so I have 24 over 9. And I say, is that the simplest form? And I say, no, I can divide by 3. That gives me 8. And I can divide 9 by 3. And that gives me 3. So then my answer is 8 over 3. That is one option that you can use as well. You divide with what you know, right? Dividing by 2 first. And then you go on until you can't divide any further. 48 divided by 42, we can use a similar approach. We divide both numerator and denominator by 2. And so you have 24 over 21. And then you look at it and say, what else can I do? I divide this by 3 and this by 3. And so I have 8 over 7. So that's another approach to use. 16 over 12. We can divide both of them by 2. We'll get 8 and 6. And then we divide by 2 again. Divide by 2. And you have 4 over 3. So notice that you can use several options. You can prime factorize right away. You can have a situation like this where there's a greatest common factor you're aware of and you just take that out. Or you can have situations where you divide by 2 and then you divide by 3. Math teaches us how to think systematically, step by step. And this is one of the areas where you can apply that. So very good. We're going to switch gears here and look at another part of this section, which deals with finding the product when you have fractions multiplying one another. Now, when you multiply, one thing that is important, one thing that we have to remember is that we can, first of all, remember your integers, that a negative times a negative is a positive times a positive is a positive, right? So when the signs are the same, we have positives. When the signs are different, we have negatives, right? So when the signs are different, we have negatives. But when the signs are the same, we get positives. So number 22, negative 2 times negative 5 over 6. So if you do negative 2 times negative 5 over 6, you can get rid of the negatives right away because a negative times a negative is a positive. And then you're left with 2 times 5, right, which is 10 over 6. This is one approach you can use. But I do want you to know that because the 2 and the 6 have common factors, you can simplify. And as a matter of fact, eventually, that's my goal for you. I would like you to simplify before you multiply, because that will reduce the work that you would have to do later on. But let's just go ahead with this method. We'll use this method for the first 2 examples, and then I'll use the other one for the next 2 examples. So you have 10 over 6. Remember, this is why we learned the simplifying fraction part earlier. You divide this by 2, you divide this by 2. Now you have 5 over 3. So that will be how you get to the destination for this particular problem. However, let's look at another one using this same approach. We have, for example, let's see a good problem here. I'm going to go with number 26, but I'm going to modify it. So instead of 1 over 2, I'm going to call it 2 over 1. Okay, so 3 over 2 times 2 over 1. Now, I can simplify these 2's if I wanted, but let's say I didn't do that. Then I would technically have 6 over 2. And then I would divide both sides by 2, or divide both the numerator and denominator by 2. I apologize, that's what I mean. And then you get 3 over 1, which is just 3. Notice that you multiply across. When you multiply fractions, you multiply across. You don't need to have a common denominator. You could just multiply across. And that gives you the next set of numbers. But the other way I could have done number 26, let's call this method 2. And you can tell me what you think about the second method, where you have 3 over 2 times 2 over 1. These can cancel right away. And that's one of the things we did back in Africa, or in Nigeria, specifically in Africa. One of the things we did was we did a lot of canceling before we multiplied. Why? Because it simplified things so that we didn't have a lot of big numbers to work with later on. You will notice that you use this same principle when you're working with rational expressions later on. So I just want you to be aware that there is a second method that you can use for that. Let's look at another problem here. I'm going to go with one that I'm going to make right now. 7 over 4 times 16 over 14. Okay, for whatever reason, someone gives you this problem. 16 over 14 can be simplified. We know that. But let's just say they give you the problem like that. Okay, you can technically cancel the 7. 7 goes into 14 2 times. You can do that. And 4 goes into 16 4 times. We can do that if we wanted. Or we can multiply across first. 7 times 16, 4 times 14. Do you see the challenge? The problem gets big. 7 times 16 and then divided by 4 times 14. But instead, if we took the 7 and we say 7 goes into 14 twice and 4 goes into 16 4 times, right? 4 goes into 4 once and it goes into 16 4 times. 7 goes into 7 once and goes into 14 2 times. Now you have 4 over 2, but the 2 goes into 4 2 times as well. So then you're left with 2 as your answer in that particular case. So I hope that you see that you can use different approaches to do these, but ultimately I want you to be comfortable with multiplying fractions, which we have videos on with more details from our pre-algebra course if you need more, if you want more examples from there. Now let's talk about quotients. When they involve the quotient as it involves fractions. So if someone says 5 over 3 divided by 7 over 5, you remember that with your fraction division, you would write that as 5 over 3 times 5 over 7. So you take the one on the right side, okay? There's no commutative property of division. So you make sure that you take the one on the right side, and that's the one that you switch and use the reciprocal of. So then you have 25 over 21. And you cannot simplify that any further. So you take the number on the right side and you flip that, and that's how you find the quotient. Example, we have negative 13 over 8 divided by negative 15 over 8. So we write that down as negative 13 over 8 times 8 over negative 15. Notice that the 8s can cancel right away, and the minuses also go away because a minus or a negative divided by a negative is a positive. So then we have 13 over 15 as our final answer for that particular problem. So that was number 48. Let's do one more problem and then we'll move on to adding and subtracting fractions. So we have 10 over 9 divided by negative 6. Okay, let's do it on the next. 10 over 9 divided by negative 6. So if you have 10 over 9 divided by negative 6, what you need to remember is that any number by itself is technically that number divided by 1. When you just look at the number, it technically, you have a 1 there. So you can flip the right side and it becomes 1 over negative 6. So you have 10 over 9 times 1 over negative 6. Now you can go ahead and multiply across, right? So we're going to use two methods. Method 1 here and method 2. Method 1 is where you multiply across. So you have 10 divided by 54 and negative 54. So notice now you have to simplify this, right? So you can divide both sides by 2. So we have 5 over negative 27 or negative 20 or 5 negative out there, and then 5 over 27. So when you have a negative in the denominator, we can write it the same way like that, okay? So 5 over negative 27 is the same thing as just saying negative 5 over 27 as a fraction. So the whole fraction, that fraction is negative 5 over 27. So this is one method. We multiplied across, right? We multiplied across, and then we moved on to our destination. The other approach to use is to take 10 over 9 times 1 over negative 6, and you basically, right away, before you simplify, you say 2 goes into 10 5 times, and 2 goes into 6 3 times. So you have 5 already, right there, and then you have 9 times negative 3, and you have negative 27. So notice when you simplify before you multiply, it will help in some ways. Otherwise, you can go ahead and do the simplifying later after you've multiplied through. I just want you to be aware of the options that you have available to you. So that was number 44. Now let's go ahead and talk about adding and subtracting fractions. So remember, with adding and subtracting fractions, we need a common denominator. We did not need that for multiplying and dividing, but we need that for adding and subtracting. So we need a common denominator. Let's start with number 56. We have 1 over 3 plus 5 over 3. When we have a common denominator in this category, we just go ahead and we can add our numerators, okay? So if we have 1 over 3 plus 5 over 3, that becomes 6 over 3, which becomes 2. This is number 56. That's how we would approach it. Number 54, we had 1 over 7 plus negative 11 over 7. So 1 over 7 plus negative 11 over 7. In this case, we basically do the same thing. We have a denominator ready to go. And so we have 1 plus negative 11 divided by 7. We add those. So that's 1 plus minus or negative 11, which becomes 1 minus 11, right? So if it's 1 minus 11, then we basically have a negative 10 divided by 7. Because 1 minus 11 is negative 10. So that's how we get the answer to number 54. So when we have a common denominator, we can just add right across. But what happens in problems like number 58, where we don't have a denominator? We have negative 2 plus negative 15 over 8. So we have negative 2 plus negative 15 over 8, plus negative 15 over 8. So in this case, we technically have negative 2 over 1. And so we have different denominators. If we have different denominators, that means that we need to basically find a way to get a common denominator. One way we do that is we multiply both the top and bottom by 8 over 8. So then we have negative 16 over 8 plus negative 15 over 8. So we can look at the left side and we say, I want to have an 8. And so in order to have an 8 in the denominator, we have to multiply both the top and bottom by 8 over 8. So that's what we're doing in number, we're in number 58. So number 58, we need to multiply both top and bottom by 8 over 8 to get what we need. Now, this is one approach. Students in some schools in Nigeria will use a different approach, and I can discuss that with you later if you want. But basically what they would do is they would set up they'll set up a line here and they would write 8, which is the lowest common denominator, and then they will basically take 1 goes into 8 times negative 2 is negative 16, and then they will do the same thing. 8 goes into 8 once, 1 times negative 15 is negative 15. So that's their approach. It's not very common in America, but it is an approach that people use. But in America, generally, I've seen a lot of students use this particular approach, the one that is very popular, where they just multiply both the numerator and the denominator by 8. So 8 over 8. And that's how we get negative 16 over 8 plus negative 15 over 8. That becomes negative 31 over 8. So that's the answer to to this particular problem. Moving on to another problem. Number 60. We have negative 1 minus 2 over 3. Again, we don't have a common denominator, but we know that this negative 1 has a 1 underneath it, technically. And so what we do is we multiply both top and bottom by 3 over 3. That becomes negative 3 over 3 minus 2 over 3. So it becomes negative 3 over 3 minus 2 over 3. So for number 60, we have negative 3 minus 2, and that becomes negative 5, and the denominator just stays with a 3. So when we have a common denominator, we just work our way in the numerator to get the answer that we need. Now, what happens when you have problems like 1 over 2 minus 11 over 6? So we have to watch the signs. We have to still find a common denominator. So we multiply by 3 over 3. And so we have 3 over 6 minus 11 over 6. So you just say, what is 3 minus 11? Again, remember, let's say you have $3 and you want to buy something that's $11. Well, you're short $8, right? So we have negative 8 over 6. That negative 8 over 6 can be simplified. We can divide both the numerator and denominator by 2, and we'll have that becoming negative 4 over 3. So that's how we will deal with a problem like number 66. Number 68. Number 68. So 68, we have, what about 11 over 8 minus 1 over 2? Again, we need a common denominator, so we multiply both top and bottom by 4 over 4. We get 11 over 8 minus 4 over 8. We just have a numerator to deal with. The numerator to deal with, 11 minus 4. So again, you take each one, what's 11 minus 4, and then you leave your answer as 7 over 8. So that's number 68. Let's do one more and then, or two more, and then we'll be good to go. Number 80, you have negative 1/2 minus negative 3 over 5. So in this case, you have to deal with several issues. The first is you have to get your signs in order, and then you also have to get your denominators in order. So let's get our signs in order. It becomes negative 1 over 2 plus 3 over 5. So that's good. But now we look at 2 and we look at 5 and we say we don't have a common denominator. We need a common denominator. So what you do is you can multiply the left by 5 over 5 and the right by 2 over 2. It's important to note that 2 and 5 are prime numbers. And so because they are prime numbers, you won't find a common factor between 2 and 5 because they're prime numbers. So you just know that you have to multiply each of the numerator and denominator by the opposite denominator. So the numerator and the denominator is being multiplied by the opposite denominator. Do you see what I mean? So the opposite denominator in this case. And so we have 5, well actually negative 5 over 10 plus, and we have 3 times 2, which is 6, divided by 10. So you have negative 5 over 10 plus 6 over 10. And then you go ahead and you can take care of the, what's negative 5 plus 6. And so we have 1 over 10. So that's how we do number 80. Let's try number 82. So for number 82, 9 over 7 minus, so 9 over 7 minus negative 5 over 3. So again, we take care of the sign. That becomes a positive, right? Negative times a negative is a positive. And then we have to take care of the denominator. We have a prime number and a prime number again. So what do? Remember what we said? If they're both prime, that means they don't have any common factors. I mean, of course, other than 1, but generally you would then have to multiply by the opposite denominator, right? And so you go ahead and you write this out. You have 3 over 3 multiplying the 9 over 7. So you have 27 over 21 plus 35 over 21. You add those two numbers together, you have 62 over 21, and that is your final answer. I hope this is helpful as you work through your problems from 0.2. Keep up the good work. If you need to take an extra day to do more of the problems, do that, but make sure you get through all the odd problems for 0.2 as well. Let me know if you have any questions. Have a great day.